Hello. Um, this will be the last lecture of mine in this semester. Um, so next week will be your exam week, next Friday. I think I want you to take a look at the announcement. I don't remember exactly, but I'm going to follow uh, uh, the announcement that I already posted. So please refer to that announcement. The test is I think, relatively simple, um, which covers both mobile technology, which is apps development, and also wireless sensor networks. Open book test, um, about a 3 hour exam. But if you want to, you can take a little more amount of time. But only the restriction this exam is that only one sitting is allowed, which means once you start, then you have to finish. If you do not finish it, it means you give up. So you have to finish up, okay, once you start. That is next weekend. Um, so I think it Friday evening, Saturday evening, and Sunday evening. Um, so officially, we three time slots are available for you to pick. So you can pick the best time for you, um, and also you have to make sure that the connection should be stable. If you have any problem, then I think you better to come to the place where there is a strong and robust internet connection. And the week after that, I believe that is the first Friday of May, which will be our last meeting. That is only for your semester project presentation. The deadline for your semester project, as I already open up the Dropbox on Blackboard, um, which is, I think, Saturday or Sunday. I think Saturday. Presumably, it's a Saturday, midnight. What you need to submit is actually the final report. That is the full extension from your proposal, which should include the work, detailed work description, and also contribution of your work to either or both mobile technologies and wireless sensor network. Um, the written final report, together with your uh, verbal presentation, are required. Those who cannot make your presentation in person in class, then I want you to record on your own and post it any multimedia server. One of the very popular and free server is YouTube, so you can post yours on YouTube. But please make sure that your video should be public. If you make it private, then no one can view it. Of course, with no view, then no grading, right? So please make sure that before you let me know what else that we need to do. I think that is pretty much what we need to make sure before uh, we start my final lecture. Final lecture for today is a little bit of the issues of wireless sensor network. Among many um, technical issues, I'm going to discuss with you about power management issue and time synchronization issue and security. We're going to start with the security issue first. Oh, wait a minute. Oh, power management. Okay, great. Not the security first. Okay, power management. Um, um, Sensor um, itself needs power many cases, not only the power required for sensing, but power needed to collect the sensors, and more power required for data transmitting. So usually sensors are, collecting sensors or activating and collecting, sending sensor data are done by microcontroller unit. Microcontroller unit needs a power supply. One of MCU microcontroller units that we looked at in class is Arduino, right? And also someone use Arduino. Many of us use Arduino Uno, and some uses Arduino Yon, which is for Wi-Fi communication. And if someone wants to do a little more powerful processing, then you need to use Arduino Mega. And there are many other versions available depending on your need. But anyway, in most cases, power is needed. The beauty of a wireless sensor network is that it activates and continue to perform the mission continually 24/7 on behalf of us. However, and also it can be deployed somewhere, any environment where human uh, cannot be involved, or do not need to. Then it needs power, and why human cannot be involved? Many cases because that is some hazardous environment where there is a earthquake or tsunami, uh, nuclear power plant uh, um, radiation leakages and whatsoever. I mean, a lot of types of disasters available where human cannot stay. Um, if we stay there, then it means that is the end of our life. So we send, for example, robots with the sensors that we want to collect the data from. Then sensor needs power. Sensor, the node in the sensor network, node means therefore it's not just the sensor itself, but sensor with MCU, microcontroller units. Therefore, it needs power. MCU has a limited data storage. So the best way to keep the data is to send out as soon as it collects. For some cases, MCU needs to be a little more intelligent. Therefore, not all the data it collects needs to be shipped out, but only something meaningful. In that way, we can reduce data transmission, which means we save power. Okay, so there are many issues that we need to consider. So let's look at the bullet points on this slide. Local power management and dynamic power management. For that, we need to consider conceptual architecture. We're not going to consider all of this, but I'm going to give you a broad idea. So local power management aspects, then we need to also take care of a processor and communication. And therefore, the microcontroller has bus communication, and therefore it needs some frequencies. Depending upon that, it determines the power of processing. And memory needs also power. And also it has batteries and some converters. Dynamic power management depending upon the task, we can manage it, the power more dynamically. That's what we need to think of. So as I said earlier, energy is needed, right? But as we deploy sensor networks, it shouldn't be big in size. It should be very small, right? Sometimes we disperse it over the air. Therefore, size and weight should be very, very small. And also, many cases we cannot replace it, or we cannot access it. So once sensors are deployed, it should be there until it lasts. So we need to maximize the lifetime of sensors. The lifetime of a sensor is much, much longer than lifetime of batteries. So power is really important. The failure of nodes more frequently caused by power. If there is no power, then sensor does not work. So power consumption. We need to, this is a little more research issues, and we need to develop the protocol, communication protocol, which consume the energy more efficiently. So we may think of self-organization uh, over the wireless network, where there are multiple wireless sensor nodes are available, and nodes are organized in certain form. If a few of those sensors battery already died, then um, another uh, a factor that kills battery consumption, battery life, is try to identify my recipient, which is a sensor. So I, till last minute, I keep sending my data to my neighbor, but at certain point, my neighbor died. Then my data transmission is useless. Or somehow, if I want to communicate, not simply broadcasting, but if I want to make sure my data to be transmitted to my recipient, therefore, uh, I need to see acknowledgement from my neighbor. If my neighbor is not responding, then I keep waiting acknowledgement from my neighbor, which um, waste a lot of power. So according to some algorithm, we can think, okay, now we need to reorganize our the topology of our sensor networks. So self-organization is also can contribute to the energy efficiency paradigm. Um, Medium access rather than maximum access, and routing protocol, as I said, depending upon the protocol, um, the route of data transmission may consume more power or less. So depending upon that, um, we can manage the power differently. And also another issue is to identify activities in the network. So some cases unnecessarily sending or waste of my sendings. So all such things needs to be considered in order to um, improve the power management. Second bullet explains the most inefficient activities are a result of non-optimal configuration in hardware and software. As I keep explaining, um, one of the nodes does not respond, but all surrounding nodes needs acknowledgement from that dead node. Then that is big. I mean, that is uh, worst configuration. Um, Another thing is unexpected overhearing of traffic. Uh, let's say I'm a one wireless sensor, and through my transceiver, I already know that my neighbor wants to send the data, but the neighbors to me is not only that sensor node, but maybe many others. Once I hear from one neighbor sensor, then I do not need to receive. I don't. I mean the replica, uh, multiple transmissions from my multiple neighbors. There's an overhearing, right? So that type of things needs to be considered. So all such things can be improved by software. I mean coding, right? So coding is very, very important. It cannot be done by hardware design. Of course, the hardware is nothing but the software that we tested, and if it is printed in circuit, then that is a hardware. So hardware is I mean, there is um, really um, nothing but hardware, but many cases anything can be software. I still remember that about 20 years ago, we never think of soft keyboard. When we are saying keyboard, the keyboard is a hardware. There's a buttons, right? We are using keyboard in your computer. But now we have soft keyboard, right? Something like that. Antenna, then so far antenna is anyway it is a hardware, right? And it's some tipping points of the antenna, some emitting signals. I think there should be a hardware, but up to that point, all others can be done in software eventually. So we are at that stage now. So power can be managed more dynamic pattern. So I'm going to point out here. And also dynamic power management can be done locally and globally. So what it does is that locally to minimize power consumption of individual nodes by providing each subsystem with the amount of power that is sufficient to carry out a task at hand. When there is no task to be processed, then we can save by pushing it into a sleep mode. In global strategy, we need to balance a workload of the entire nodes. As we looked at in the previous slide, overhearing globally, if we can manage it, who will be in charge of sending to a specific neighbor node, then all others do not need to do the same mission repeatedly. That is global management. Okay, this is a power management, and there's a lot of other deeper considerations have been developed for many years in wireless sensor networks. So those who are interested in this power management issues, I want you to study further. Okay, another issue is the synchronization. Sensor data are more meaningful if we know the time. There's a timestamp together with the sensor data, then we know that is meaningful. But we send out, we distribute to multiple sensors all over the target area. Then and also where there is we have a sensor, I mean center uh, server. Okay, server not necessarily in that targeted area, but maybe somewhere in remote location. As sensor data received at by the server, center server needs to know where it comes from. So sensor data should have a geocode, the location, and also time. And comparing the time, we can see uh, some trajectory of that event when the event causes the sensor data. Then timestamp is very, very important together with the location information. Suppose, however, um, time, I mean, system clocks are not synchronized, then um, we cannot figure out which one occurs before which one, right? So there's some precedence of the occurrence uh, may be very, very important. That is the key point. So that location 1 and the event occurs at time t1, but it moves to location 2. By the way, that is the time t2. So time t1 is earlier than time t2. So we need to have that relationships. So with the temporal and geographical relationships, we can conclude more clear um, the idea. So each node needs to be synchronized. How can we synchronize them? Well, initially, let's say if we have 10 sensor nodes, we want to disperse them, then we set the time together. So they are initially synchronized. They're all somewhere. Um, but depending upon the power, clock tick may not be sound, right? Maybe some clock lagging, some clock leading, the different, somehow some issue, right? Not only that, there is a situation that, oh, there's one of the sensor node is died. So we want to replace it. So we send a new sensor node to that place. Now, there's two different times. Time that we are earlier synchronized, and then a new sensor node as a new time. We do not know they are really synchronized. So synchronization is very, very important. As far as all the sensor nodes are synchronized, then as I explained, we will have a more meaningful and clear um, uh, decision that we can make. But unless otherwise, then although we make some decision, may it may lead um, um, unacceptable or malicious um, consequences, which is not good, right? So how can we do synchronize? The factors that we need to consider is clock offset, synchronization, clock rate, clock skew, and all such things. So for example, this is a real time, and this is a clock time. We for example, some of the sensors start from here, okay? So it moves that, and some clocks start from here, but they reach two different clock time because um, some clocks slower than the other fast clocks. So it end up having, so we start from here the same time, but at another time, as time elapsed, we may have, it start with the same sensor, same time for different sensors, but we end up having two different times. Real time, we time clicks in real time. So this is the time that we expect, but since the time the sensor sent to us is two different times. This guy sent to us that time, and this guy send it to us the other time. So we apparently see, oh, two different times, which means this may occur earlier than the other, which leads to the wrong consequences of our reasoning. So that is the issue, right? So time synchronization is very, very important. Um, so external synchronization, internal synchronization. Clocks are synchronized with the external source of time. So there is a reference clock. So always, hey, we have a center node. So the center node always keep checking each sensor. Hey, this right now this is the time. Do you have this time? And we keep sending that. Okay, make sure that they are all synchronized. Or internal synchronization is that among themselves, among sensors, they are talking each other. To my neighbor, hey, what time do you have? Oh, I have this time. You have that time. Okay, uh, let's reset our time. So I can set my time to your time or the other or the average. So we can have that synchronization, right? So um, why synchronization is important? Um, you probably understand already, but this slide explains. For example, if we are now using GPS, uh, then not necessarily GPS. Okay, this is a sensor, so we have a moving sensors. Okay, so sensor one and sensor two and sensor three, all of those sensors are moving. Um, Sensor one, and therefore they have in different location, different distance, right? This guy sent it to me. When I receive this sensor, let's say it sends sensor data from sensor one arrives earlier than sensor 2 and sensor 3, it doesn't mean that that event occurs earlier, right? Depends upon the time and depends on the distance. So all such factors needs to be considered. But anyway, time this guy says, hey, I got this sensor data time t1. This guy says, oh, I got this sensor data at time t2 and at time t3. Then we need to make sure that time t1 is really ahead of time t2, which is ahead of time t3. We know that if all the times are synchronized, right? Um, if we want to synchronize, then let's say like internal synchronization, or that is okay for external synchronization. If it is external synchronization, then node I will be some coordinator. If we are talking about internal synchronization, then these two nodes are at the same level, so they are just neighbor. In any case, node I uh, sending the time stamp to node J. Hey, this is my time. When node J receives timestamp from node I, then time already passed, right? Certain time passed, which is the t. And this is time t1. So my time t2 is t1 plus time delay and some maybe delta with some error or some other factors, some other unknown, right? We cannot say that t1 plus d only, some factors. Okay. D is the propagation delay. Delta is something, some error. Okay, it some tolerance. So we need to figure that out. Okay, at time t2, when it receives, then take delta into consideration. T2 says, oh, okay, my time now is t3, so t3 is sent to t4. Then node I needs to think, okay, his time is t1 plus d plus delta and whatever the processing time here, and then another the round trip returning trip delay, that and again the delta. In that way, node I can figure out the time of node J. Okay. Another way is that it's similar to that, right? So a two-way message exchange or single way, they are very similar. Okay, so synchronization is a very, very important issue. Third issue that we are going to consider is security. Wireless sensor node has security issues. So we all know that there's a CIA security models, confidentiality, integrity, and availability. So confidentiality ensures that only the intended receiver can read and interpret a message. Unauthorized access is prevented. That is confidentiality. Integrity is to ensure that a message cannot be modified. So the data at the sender side should reach it and therefore available at the receiver side. They should be identical. Availability is to ensure the system and network is able to perform its task without interruption. Okay, often measured in terms of a percentage of uptime and downtime. So uptime over downtime. So unauthorized use needs to be kept away from our communication. So we have to be very careful of eavesdropping. And integrity, another attack is man-in-the-middle attack, by which data may be modified. Then integrity is not kept anymore. Availability, so it should be, data should be available, which means there is no denial of service. the security issues. Not only CIA model, we also need to think of authentication. Usually authentication is to check their login name and password. On the other hand, authorization is to consider once user is authenticated, therefore user comes into our territory, it doesn't mean that that user can access all the data which is available in my territory. Depending upon the roles, depending upon many factors, data may or may not be available for the user to use as authorization. Non-repudiation, the process of providing that person or device has performed a certain transaction and transmission. As far as this is not contradictory to authorization. Authorization is legal, but if authorized, then it should be non-repudiation. Digital signature is another issue, right? For authentication and integrity, also non-repudiations. Current communication to make sure that both are trusted, then we need to share digital signature. Digital signature can be generated and also authorized by some trusted authority, right? Cryptography is also a very, very powerful tool if you want to keep the privacy so that no one can see the data of yours. So you know the key. You're the only one who knows the key, right? Two types of keys are considered: symmetric key, and the key to encrypt will be used to decrypt. That's symmetric. Asymmetric key is the keys are not the same. So there are two pairs of keys available. Okay, so keys are generated pairs. So one pair will be used for encrypt another pair. Therefore, only the key that it can decrypt it. All right. So denial of service, that is also very, very important issues in Wi-Fi. Therefore, that is also potential security issues in wireless sensor network. All others are very, very similar, right? Similar that you can see in many cases. So I wanted to take a look at this, but I mean those all can be found in many other courses. So all the security issues that you learned from other subjects also available here. These days, the very popular security issue is ransomware. So ransomware may be also available in wireless sensor network, right? Scenario of a ransomware in wireless sensor network can be found very easily. One of the examples that I can introduce to you is as follows. Homes are now digitized and very intelligent because you can monitor your home while you are away, right? Your home is connected to the internet. Of course, therefore, you can monitor and control um, all sensitive the equipments installed in your home. Ransomware may play uh, in that scenario in a way that attacker con- can take the control of your home, and then you can that attacker request ransom from you. Okay, I have all the control over your home. I locked it up, so you cannot freely access into your home. So I need ransom. That type of things is very, 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 very common. Will be uh, will occur in the future. All right. I think this is for um, the conclusion of our sensor network. Now I want to uh, share with you um, the wireless sensor and phone networking. Okay, so we looked at so far apps development and wireless sensor development. How integrate them together. Among sensors, we know, um, well, if you want to, if we want sensors to communicate among themselves, then we can, we may use some transceiver. Transceiver that we looked at in our class is the Eurasian Scientific company developed NRF, radio frequency 2.4 gigahertz, L for I think a low energy, and 01 plus model transceiver developed. So this is so robust. Another way that you can do is using Wi-Fi. So Arduino Yarn may be used. But in any case, if sensors needs to talk another sensor, then you need to have some processor. One of the processors that we may consider is Arduino. So Arduino with NRF24L01 plus or Arduino Yarn, right? There's a sensor part. Smartphone has smartphones is available and open up uh, the communication channels for Wi-Fi signals and Bluetooth signals. Cell signals, that is also possible, but there's no sensor that can generate cell signals unless it needs GPRS. Okay, what is that GPRS? Packet radio system, general packet radio systems. Other than that, we can consider either Wi-Fi or Bluetooth, right? This is not negligible, right? But this is also possible. Anyway, but as far as we have GPRS. Okay. Um, it's kind of a sensor, right? It's not really sensor, but some processor. It's nothing but another phone, right? If you have a phone, we have that, and another phone. That phone is like a Arduino shield, but and therefore it can communicate through and using that GPRS signals. Um, uh, we have this. We ordered this last time for IASP 560, but this device arrived at the department after the last fall semester ended. So in this fall, of course, we have a GPRS ready from the beginning. To make it useful, I want you to have, for example, a SIM card. So each one, who you want, if you want to work on GPRS, then you need to have, you need to subscribe your own SIM card. So for example, you can buy SIM card from T-Mobile, which is nothing but you will receive one prepaid phone number. Okay, so from that, uh, and also you can program the way that we did for this sensor network on Arduino Uno. So you can plug this GPRS on top of that Arduino Uno, so your phone can communicate with any sensors on your Arduino Uno. Okay, which is neat. Um, and also very, very exciting. But today I'm going to introduce to you this Wi-Fi and Bluetooth integration. And this is, we are talking about the integration. If we have sensors and if we have an iPhone, then we need to integrate them. Another way of integration is sensors and web page. Okay, isn't it so interesting? So you have sensors is deployed. So sensor may send the data to your web page. So your web page may visualize the sensor data continually as far as sensors are alive. So the issue here is that sensor data is dynamic and streaming. However, web page is normally static. There's no connection between. So what we need to do is that sensor data can be placed on top of MCU, microcontroller unit, so that microcontroller can send the data. And the web server will have JavaScript running. So this JavaScript keep receiving sensor data. Still, this MCU and your web page, there is a big gap. So what we need to do is that we need to open the socket. So socket can listen. The idea there is this is your web page where there is a P5 serial port is running, and this is the other extreme end in this architecture, which is microcontroller, where there is a sensors. In between, we have a serial server. Web socket to serial server is running. Ideally, this is a fancy, but my personal experiments somehow unsuccessful because um, this architecture is not fully ready, but will be available in the near future. Okay, so you can take a look some of the website that I posted here and also there if you are interested in. Okay. All right. So now let's go back to the integration between sensor network and iPhone. There is a Bluetooth a module developed by a Nordic scientific company, a different model, NRF 8001. So there's a BLE. LE stands for low energy. It looks like this, right? And you install this and download uh, UART from GitHub, unzip, and put it into your Arduino library folder so that your Arduino IDE can understand this BLE UART. Okay. So here, something like this, you can choose this from your IDE and an Arduino Uno uh, can embed and can serve Bluetooth by this kind of wiring. So wiring is simple. I've done this successfully. So this guy can communicate with your iPhone. So there is an iPhone app also available like this. So you can install it. So that not much that you need to do only on iPhone. But here, by having this, what you need to do is using other pins available here, you can plug sensors, okay, and send these sensor data through this Bluetooth communication so that your iPhone receives data, sensor data. This is apps. At the same time, you could see from your serial monitor at Arduino IDE. This is Arduino IDE, right? This is iPhone port, and this is your Arduino. So both are talking about same data. If we want to enhance this apps, then you need to do more Xcode work. All right. All right. This is all I can say in this semester. I hope you learn something from both. Each, I mean, we have two modules discussed together in one semester. Of course, one module may last in one or more semesters. Sensor network itself may last longer and longer, which may be discussed deeper and wider for many semesters, similar to iPhone, but we put them in one semester. Uh, Someone might have a great idea. Meanwhile, some other students may uh, have some difficulties following. But I hope this material simulates you so that in the future, in the near future, uh, your career, if uh, you are requested to conduct this type of work, don't be afraid and look up this material and start from there. That is my contribution to you. Okay, so what is next? Um, Next weekend is your exam, and following week, I mean Friday, is the final meeting for your presentation. Those who cannot come to your presentation, please let me know. Let me know uh, so that I can expect some URL submission from you. All right. This is